This Algebra 2 lesson is Solving Radical Equations, Lesson 6.6. Let's take a look at a warm-up that really is Algebra 1 kind of problems, but the exact same steps you used in Algebra 1 will be the same steps, plus one or two more, as you solve equations with radicals. So take a minute and solve each of the equations on your own piece of paper, showing your steps as you go. So hopefully your equations look something like this. Number 1, you subtracted 6 from both sides, then you divided both sides by 5. Number 2, first you divided by 2. You're trying to isolate the variable. Then you ask yourself what's happening to your variable? Well, it's being squared, so the opposite of squaring is square rooting. Don't forget here that exponent of a 2 indicates that you have two answers, positive 4 and negative 4. So let's look at the first two examples of our lesson today. They look very similar to the warm-up problems, only a radical has been thrown in number 1. Exact same steps. Add 6 to both sides. Then get rid of the radical by squaring both sides. Once that is done, it goes back to being exactly like your warm-up number 1. Divide both sides by 5. Number 2 will start the same way. Divide both sides by 2. And now to get rid of our exponent, we are going to raise the left side to the 3/2 power and the right side to the 3/2 power. Remember your algebra exponent properties. When you have a power to a power, you multiply the two exponents. Therefore, your two exponents have a product of 1, and you have gotten your variable isolated all by itself. But 16 to the 3/2 power, you could put in your calculator, but let's look at it without a calculator. The denominator of that fraction, of 16's exponent, the 3/2, the 2 in other words, is the index number. That's what in essence goes inside the hook. You are square rooting 16. After you do that, then you should cube it. Square root of 16 you know is 4. Actually, it's plus or minus 4. Then you'll cube that number and get positive or negative 64. Let's do two more examples. As you look at this problem, had the radical sign not been there, 2x plus 7 equals 3, it would have been a very traditional Algebra 1 problem. But before you can get at your variable term to try to isolate it, you have to get rid of the cube root. And the opposite of cube rooting is taking something to the 3rd power, cubing it. So you need to cube the left side and cube the right side. Those cancel each other out on the left side, and the left side becomes 2x plus 7, and then 3 cubed is 27. Now this does become an Algebra 1 problem. Subtract 7, divide by 2, x is 10. One final example. A little bit more complex because you have a variable on both sides, but the first thing you need to do is get rid of that radical. So the opposite of square rooting is squaring. So we have to square both the left and the right side. Now be very careful on the right side. You cannot distribute that square into the parentheses when it's a sum or a difference. It just doesn't work that way. You need to take x plus 1 times x plus 1. You're squaring the entire binomial. The left side's a piece of cake. The square root and the square simply cancel each other out, and the left side becomes a 7x plus 15. The right side, when you in essence use FOIL with the x plus 1 times x plus 1, gives you x squared plus 1x plus 1x plus 1, and then you combine your like terms. Now you have a more complicated equation, lots of variable terms everywhere. We need to condense it. Let's combine all of our like terms. So I'm going to subtract 7x from both sides and subtract 15 from both sides. Now I have 0 is equal to x squared plus negative 5x plus negative 14. What we have on the right side of the equation is a quadratic. We have a lot of options for how we solve this. We could use the quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4ac. All of that divided by 2 times a, but that's a pretty long process. Let's double check what I've given you some hints on with my multiplication dot above the negative 14 and my plus sign above the negative 5. Let's see if this equation will factor. Are there any factors of negative 14 that sum to negative 5? Indeed there are. negative 7 times positive 2 give you a product of negative 14, and negative 7 plus positive 2 give you negative 5. So we have now factored that quadratic. Why did we factor it? Think back to 3rd grade when you first were learning your multiplication tables. The only way you can have a multiplication problem equal 0 is if one or the other factor is 0. In essence, I have two factors here. I have yellow box times blue box, and that's the reason why I factored it. I created a multiplication problem where either the yellow box has a value of 0 or the blue box has a value of 0. Then you solve each of the little mini equations and you see that you have two possible answers. Now realize, as we went through our steps 100% correctly to solve this equation, it is possible that the math that we did to get us there, even though it was all correct, could give us possibly what we call an extraneous solution. We found it accurately, but it might not actually work if we go back into the original equation. So you must check both of these answers back. If I put 7 in place of x, I have 49. Add it to 15 and then square root it. Remember that number. Then put 7 in place of x on the right side and you get 8. Square root of 64 is 8. 7 plus 1 is 8. 7 works. Now let's try negative 2. Negative 2 times 7 is negative 14. A little worrisome when you have a negative number, but negative 14 and 15 is 1, and when you square root 1, you get 1. But when you put negative 2 back into the right side of the equation, negative 2 and 1 is negative 1. What you ended up with on the left side is positive 1, and the right side you had negative 1. Clearly, negative 2, when you put it back in the original equation, does not make the left side equal the right side. So we must throw that answer out, and only positive 7 is an accurate answer.